Welcome everyone to Learn Competitive Programming with Code Shift channel. I'm Nishchay Manwani and I'm going to teach you about number theory today. So I have a special lecture today on problem solving. I will be solving two problems in this 1 hour session. And the first problem would be selection battle. This is a problem on game theory plus number theory. And there is this second problem called expected greatest common divisor. This is also a problem on number theory. So in this session, in this 1 hour session of problem solving one, I will be solving two problems related to number theory. And this is on with Unacademy, right? So a short introduction about myself. I'm Nishchay. You guys might know me as Zeusors at codeforces.com or nm at codechef.com. I recently joined the Unacademy platform as an educator. You can see my profile over here, which is unacademy.com slash at the rate nm. So in this program of competitive programming at an academy, which you might have heard of, what will you get by joining an academy in competitive programming? You'll get live interactive classes where we would be able to interact with each other. You would be asking me doubts then and there, and I would be solving them, and I will be asking you questions and you can solve them by your own, and we can interact with each other and try to see how are you learning right now. There will be practice, there will be relevant problems related to every topic that I would teach. So I personally go on CodeChef and search for problems that are suitable for the topic that I'm teaching. So you don't have to do that on your own. I would be giving you the problems that you have to practice on. And then there's doubt support. So me, as well as many teaching assistants on an academy, would be there to solve your doubts any time of the day. So personally, I generally try to solve any doubts I have. Most of the people feel the same. So teaching assistants plus me would be solving your doubts 24/7. And that's really important in competitive programming, right? So educators, we have a list of many talented educators, which have a very strong background in competitive programming. There are people who have gone to ICPC World Finals. There are people who have IOI medals. And then there are people who have landed, dream jobs like at Google, Flipkart, LinkedIn. There are people who have many high ratings on Codeforces or CodeChef, right? So there are people like Tanush Khattar, two times world finalist in 2017, 2018. Uh, there are people like Deepak Kaur, world finalist 2020. Himanshu Singh, world finalist ICPC 2020. Then there are people who have won IOI medals, right? Like Arjun P, IOI 2015 bronze medalist. Murugappan, who is a software engineer at Google. And then there are many people who have high Codeforces or CodeChef rating, like me or Pulkit. Me personally, I am currently the All India rank 3 on Codeforces and All India rank 12 on CodeChef, right? There would be many topics taught in this program. There are courses like Introduction to Programming, Java Foundation, C++, Python. These are if you are just getting into programming, right? You don't know much about competitive programming itself. But if you want to go to the basics of competitive programming, there is basic data structures, a number theory, which I'm taking currently, recursion and DP, sorting, greedy, etc. These are the basics that you have to know in competitive programming, right? And then there are the advanced competitive programming stuff like segment trees and graphs, computational geometry, advanced dynamic programming. Then there's the miscellaneous as well, which will cover ICPC regionals plus world finals problem solving. Himanshu Singh is taking this one. So he's also a world finalist himself. So you can learn from him which problems are interesting and how they are solved, right? So these actually are the live courses right now. I'm currently on my 7th lecture on number theory. All of the previous lectures that I have taken are available at an academy. So you can go back and watch all of them and then ask me doubts if you have on any lectures, right? I will be available there. So these are all the courses that are going on right now. This is the platform where you can ask your doubts on CodeChef. This will be where the practice problems would be. I have currently like 20 or 30 problems there. So you have many problems to solve from, right? And the pricing is such that you can get a 12 months package for less than 22,500 per month if you type the code NM. But if you do out, you can get for the subscription at 1 month for 1,000 rupees 1 month, right? So you can get the subscription for 1,000 rupees 1 month if you type the code NM in the referral code, right, in the subscription bar. So this will be if you want to see my plus courses. I would also be taking special lectures, so you can come watch them as well, right? Upcoming free classes, there are many free classes as well scheduled, right? uh, you can go watch them currently if you want to see how the live interactive classes works, and if you do like it, you can take the subscription, right? So without any further ado, uh, another thing I want to specify, I would be taking doubts in this class, but because of the YouTube chat and it's also streaming on Facebook Live, you can ask me all of your doubts. I will be answering your doubts at the end of the lecture. So if you have any doubts, just ask them and I would see them uh, after I have completed both of the questions. And then I would be answering all of the doubts you have. They may be relevant to the topic. I would be answering those first, or they can be off topic as well, right? So let's go to the first problem, which is selection battle. The problem code is DWW19J. Tanya and Divesh once took part in a team programming competition where they had a team of 3 members. The third member of the team, let's call this person as X for simplicity, is the reason why they're fighting with each other today. There is another team programming competition coming up where programmers can take part in a team of 2. Now, both of them want to team up with X for this upcoming team programming contest. So both of them have mutually decided to conduct a selection battle. Whoever wins this will team up with X, right? Simple. Initially, they have an integer n. This was the story part where they are just telling that these two are going to play a game, and whoever wins in this game is going to team up with X, right? Initially, they have an integer n. Now comes the game part. What is a game? The part which we are interested in. The rules are as follows. Both players alternate turns. Tanya makes the first move. In each turn, a player can choose an integer k where 2 is less than equal to k is less than equal to n and n mod k is 0. So what does this mean? N mod k is 0 means that k must be a factor of n. Example, let's say I have n equal to 15, right? Then k can be 3 because 3 is a factor of 15, or k can be 5 because 5 is a factor of 15, or k can be 15 itself because 15 is to a factor of 15. But it cannot be 1 because of this condition, which states that 2 is less than equal to k is less than equal to n, which means the number cannot be 1, right? What will we do with this k? We will set n is equal to n by k. This is happening in one move. We are selecting an integer k, which is a factor and not 1, and setting n is equal to n by k. A move after which no other legal move can be made is called as the last move. The player who makes the last move loses. Now, here is the really interesting part, right? Generally, what happens in game theory problems, I'll call this part a move after which no other legal move can be made is called as a last move. Uh, Instead of, like the last move, I'll call this as a dead end, right? So when I can't make a legal move, I'm in a dead end. So generally what happens in game theory problems is when I get to the dead end, I lose. But in this, the player who makes the last move loses. So if I'm giving the other person the dead end, then I'm going to lose, right? The person who is getting the dead end is going to win, right? Assume that both players play optimally, and it's not written here, but most probably we have to output which person is going to win. Tanya, if Tanya wins, else Devesh, right? The description is just t test cases and a number n each time. The constraints are interesting. There are 50 test cases and 2 is less than equal to n is less than equal to 10 to the power 9. Or there is a subtask 1 where test cases are up to 10 to the power 5, and n is up until 10 to the power 6, right? So there are two kinds of subtasks. One is up until 10 to the power 9, but the test cases is low. And the second is test cases is high and n is up until 10 to the power 6, right? So the sample input, now I'll be explaining the sample input in the whiteboard, but let's look at the sample input first. So there are two test cases. If the number is 14, Tanya is going to win. And if the number is 2, Devesh is going to win, right? Tanya was the person who's playing first, right? So let me switch to my whiteboard and explain this problem properly and try to reduce this problem, right? So we have the problem name is selection battle. Right? We have an n each time. In the, let's say, examples, we have 14, right? Tanya is going to pick a factor of it and make it n by k. So 14 has four factors: 1, 2, 7, and 14. Discard 1 because that cannot be used. We have seen in the problem that 2 must be less than equal to k is less than equal to n. So if she chooses 2, the number is going to become 14 by 2, which is 7. If she chooses 7, the number is going to become 2. And if she chooses 14, the number is going to become 1, right? Now, let's say what if she chooses 14, she's going to lose. Why is she going to lose? Let me elaborate. So let's take another example before we go back to that example first, which is, let's say n is 1, right? What is going to happen now? It is not given in the test case, n cannot be 1, but I'm trying to think what would happen if I do have the number 1. What moves can I make? 1 has only one factor, which is 1 itself, right? And we know we can't choose 1. So our choices are actually a null set, right? That means we cannot do anything here, which means this is actually a dead end. So remember, if I do get the dead end, I'm winning, which means the other person is losing, right? So in here, she's making the other person win, right? In here, in the 14th case, she's making the other person win. So she's going to lose here. So of course, in either of these two situations, or in both of these situations, she's going to win. Let's see how is she going to win in this, right? Before that, let's take another example. What if our n is prime? Some prime p, right? Prime p has two factors. It's by the definition. It is a number 1 and itself. So we cannot choose 1, right? We cannot choose 1. So we have to choose p. So what we are going to do is choose k is equal to p and make n is equal to n by k, which is p by p, which is 1, right? Wait a second, let me just, right. So in here, what is happening, that she's making, the person who has selected P is making the other person win, right? So the person who had the prime P is going to lose every time because he cannot select anything other than P, right? He has to select that number P itself. So the person who has the prime P is going to lose every time, right? So let's see in these examples, when the number was 14, in here, we're making the number as 7. So in here, the person who is getting 7 is going to lose. So Tanya is going to win, right? Also in here, the number is getting 2. As 2 is prime, the other person is going to lose. So Tanya is going to win. So she's going to select either 2, either 7, and she's just going to win, right? Let's look at the other example as well, which we had, which was, I think, let me just look at what the example was. It was 2, right? So we have already seen what is going to happen in the case of 2. It has two factors, 1 and 2. We can't select 1. We are going to do 2 is equal to 2 by 2, and the other person is going to win. So we are going to lose, right? So in here, Devesh was going to win. Tanya was going to lose, as Tanya is the person who's making the first move, right? So up until now, we had two observations. At n equal to 1, we are going to win. We are going to win, right? Win in quotation marks, because it's not according to definition in the question, but I'm making this definition by myself. In the question, it's the definition that whoever makes the last move loses, right? But in here, we can't do any moves. So I'm assuming that the other person did the last move, and now I'm at a dead end, right? Now I'm at a dead end. At n is equal to some prime p, we are going to lose. And this isn't the only losing condition. There might be other losing conditions as well, right? But we haven't seen the other cases yet, right? So, but at any prime number p, we are going to lose for sure. And at n equal to 1, we are going to win. Let's look at the case when n is a composite number, any composite number, right? Composite, let's say some n, right? So in here, n can be factorized as the product of some prime numbers, right? P1 into P2 into P3, etc. up until Pk. This is a property in number theory that any composite number can be factorized into its prime numbers where k is greater than or equal to 2, right? So what we are going to do here is we are going to take k is equal to P1 into P2 up until Pk minus 1, right? This k is going to be, let's replace this k with actually t, right? So it doesn't cause any confusion. So the number of primes is actually t here as well. It's not k, is actually t. And here as well, it's actually going to be t minus 1, right? So the confusion is avoided. This k is a number that we are going to select in this move, and that I'm setting as p1 into p2 into etc. but the pt minus 1. T minus 1 is going to be greater than 1, so we can be sure that this whole number is going to be greater than 1, or greater than or equal to 2, right? And then we are just going to do n is equal to n by k, which is just going to be pt. And in here, we know if a person is left with only a prime number, he's going to lose automatically. So if the other person is going to lose, I'm going to win, right? Let me write that down as well. If the other person is losing, I'm winning. This is really basic. It feels like I'm teaching an English class, but this is really important because many times when you're doing game theory problems, your mind is so occupied with whatever maths is happening over here that you forget this simple fact, right? So in here, n, when I'm at n is composite, I'm sure that I can win, right? I'm winning because I do have a winning move. I can just make the number a prime number itself, right? So I can just pick the number, pick k is equal to this, and make the number prime itself. So I'm going to win every time the number is composite. If the number is prime, I'm going to lose. And if the number is 1, I'm going to win, right? So the solution would be simple. We just have to the solution overview here. We just have to check n is prime, right? If it is, then Devesh is going to win. And if it is not, Tanya is going to win, right? Now, how to check if n is prime? There are two conditions. We can either go the normal primarity check way, which will take big of root n time, but this is too much for, test cases 10 to the power 5. It was written t less than equal to 10 to the power 5 and n is less than equal to 10 to the power 6 for the subtask 1. This is too much for that, because here uh, square root of n would actually be 10 to the power 3 and t is 10 to the power 5. So it would be around 10 to the power 8. And this is approaching the dangerous area that I'm not sure these many steps can work or not, right? But this would be actually be fine. This is not okay for this subtask. But the second subtask, which is t is less than equal to 10 to 50 and n is less than equal to 10 to the power 9, this is actually fine for that, because it's just 50 into 10 to the power 9 root is 10 to the power 4.5, which is around 10 to the power 6, right? 10 to the power 6 into some 3 or something, but it's around 10 to the power 6, which is going to work. So what we will do in subtask 1 is we will make a sieve of Eratosthenes, which will cover up numbers up until 10 to the power 6. We will do this in big of n log n times. And then we can see for each number which is less than 10 to the power 6, is it a prime just in big of 1, right? So we have to apply the sieve method and the primarity test method both in the same equation. I'll show the code now and make you understand what I'm talking about. But if you want to understand these concepts, like, oh, how do we do primarity test? What is the sieve over thinness? Right? You can check out my courses or my special lectures. I have taken these concepts in special lectures as well. Those are currently free and at Unacademy, right? So you can go and check it out. But I'm going to go and code the solution so you guys can understand. So let me just share my screen to my Visual Studio Code, right? So what I'm going to do here is first, I'm going to declare a big N, which is around 10 to the power 6 plus 5, let's say. This would be the case where I'm making the sieve, right? So I would have some Boolean prime of n, and in the start, what I'm going to do, I'm going to declare all of the primes, all of the numbers as probably prime, right? So that would be true for all numbers. And then I'm going to declare PR0 and PR1 are actually false. And then I'm going to go from int I equal to 2, I is less than n, and I plus plus. If I do find a prime number here, right, then that number is for sure prime. Up until now, it was just probably prime, but now it's surely prime, right? And then I'm going to go on each of its multiples. 2 star j is equal to 2 star I, j is less than n, j plus equal to I, and make prj is equal to false. This will set all of the multiples of this number as not prime. These are surely not prime, right? And after this, what we can do is just start the test cases. The number of test cases here would be NTC. I would input NTC first. And while NTC minus minus, if let me input the n as well. If n is less than capital N, that means it is less than 10 to the power 6, right? So we can just check if it is prime from the array we have declared. So if PRN, we are going to output Devesh. I'm not sure what was the name. I think Devesh or Dinesh. I'll check that from the problem. Wait a second. Yeah, it was Devesh. Else, I'm going to output Tanya, right? Else, we have to do a primality test in big O square root n. So in here, excuse me. So in here, what we are going to do is we are going to just check, is it currently prime? I'm going to declare that as true. And then I go from int I equal to 2, I is less, I star I is less than equal to whatever the number we have, let's say n, right? And I plus plus. If I is a factor of n here at any point, and n is divisible by I, right? Then that means S prime is false. And we can just break here. And then we check the similar thing that we had checked before. If S prime is true, just output Devesh, else see out Tanya. Right? So these are the two methods by which we check for prime numbers. One is the C over Eratosthenes, which I have declared above. And here is the primality test up until square root of n, which I have done in the below part. Let me make this work for the examples. The examples were 2, 14, 2. So it's coming out to be Tanya and Devesh, which should be the answer. Let me switch to my Chrome tab and submit to see if an AC is coming or not, right? So I've copied the code here, and let's submit in C++ 14. Hopefully it should be accepted, but if it's not, there might be some error in the code, right? The idea is similar to this. All right, so it's a correct answer. So this is how we are going to do this problem, right? So let's, before going to the next problem, if currently, if there are any doubts relevant to the topic, you can ask me. But then I would uh, talk about the competitive programming program that we have at Unacademy, right? So in here, if you have joined the uh, lecture at a later point from the start, just a short introduction. I'm Nishchay Manwani, currently taking a course on a lecture on problem solving, where I am solving 2 problems on number theory, right? So you guys might know me as USORS at Code Forces or NM at Code Chef. I'm also recently joined as an educator at Unacademy, right? So what will you get on the competitive programming program on Unacademy? So you will get live interactive classes where we could interact one-on-one. You would be asking me doubts, I would be answering them, or I would be asking you questions and you would be replying to them, right? You will get all the relevant problems to whatever topic is being taught. I, like personally check all the problems which are supposed to be shown, and you can see those problems. And there will be doubt support. All the teaching assistants and me included would try to get your doubts sorted every time, right? The educators are, again, like I've told you about in the start of the lecture, the educators are really strong, do really have a strong background in competitive programming. There are people which have gone to the ICPC World Finals. There are people who have won IOI medals. There are people who are working in like dream companies like Google, Facebook, Amazon, Flipkart, right? uh, and then there are people who have high ratings on Code Forces or Code Chef, right? There are like Tanuj Khattar, who have gone to the ICPC World Final 2 times. Himanshu Singh, also world finalist. Deepak Kaur, also world finalist. Arjun P has an IOI bronze medal, right? Then there is Pulkit, currently a master on Code Forces and a 6-star on Code Chef. And me, I'm an international grandmaster on Code Forces and a 7-star on Code Chef. Uh, What this means is I'm right now at All India rank 3 on Code Forces and All India rank 12 on CodeChef, right? So all of the educators are great. They would know the doubts you have, right? It would be really efficient to ask your doubts to these people than to your colleagues. Then there is topic wise structure. We are going to like explain beginner topics as well: Java, C++, Python, or programming. Like if you're just getting into programming, there are those kinds of courses as well. But in basics of competitive programming, you would be getting number theory, basic data structures, sorting, searching, greeting. These are all the basics that you would require to get good in competitive programming. And then there's advanced as well, which includes segment trees, trees and graphs, computational geometry, advanced dynamic programming, etc. And there's also miscellaneous topics such as ICPC regionals plus world finals problem solving, right? This is being taken by Himanshu Singh. So Himanshu Singh is, like talking about all the ICPC world problems or ICPC regional problems that he has encountered and found interesting. So, and that will be great to watch, right? So these are all the not upcoming, these are currently live courses. You can go back and see all the lectures I have taken before this as well. So there is no pressure on you to attend live lectures, right? It would be better if you want to ask your doubts directly in a lecture, but I am also available other than my lectures as well. So there is really isn't any pressure on you to attend all of the live lectures, right? uh, but yeah, you can follow the lectures on your own pace. Teaching assistant support, this is a forum where the teaching assistants would be helping you with your doubts. The course wise practice problems, here all of the course problems would come, right? And the pricing is like currently there are some special lectures, you can go and check them out, and these are free. If you like the special lectures I have taken currently on Sivo, Veratos, and S, there are also lectures taken by other people as well, right? Go check them out. If you like the teaching method and the people there, then you can buy the subscription, which is for 12 months it's less than 2,500 per month. But if you're trying to join for another demo period, like for a month, let's say, then you can currently join for only 1,000 per month, right? For the first month, right? And the referral code is NM. So initially I think it will be showing 6,000, but if you type the code NM down here in the subscription page, then these pricing would be shown, right? So yeah, this was all about I wanted to talk about Unacademy. Let's get to the second problem, which is expected greatest common divisor, right? Uh, I'm sorry if I did miss any doubts. Actually, I would be taking all of the doubts at the end of the lecture. So if you do have any doubts currently as well, so just ask me those doubts at the end of the lecture, right? Uh, Before going to the doubt session, let's talk about expected greatest common divisor. So this is a problem that I found really interesting and wanted to share it with all of the people. Uh, so in this problem, there are several integers x0, x1, etc. up until xk minus 1 are randomly chosen from some intervals, right? These integers are randomly chosen from some intervals. Namely, x0 is randomly chosen between a0 and b0, inclusive. X1 is randomly chosen between A1 and B1, sorry, inclusive, and go so on. So X0 is chosen between A0 and B0, X1 is chosen between A1 and B1, X2 is chosen between A2 and B2, up until Xk minus 1 is chosen between AK minus 1 and Bk minus 1, right? We are interested in the expected value of the greatest common divisor of the Xi, which is the average of, so this is important, we are interested in the average of this value, which is GCD of x0, x1 up until xk minus 1 over all possible choices of x0, etc. Right? That's obvious. So whatever random numbers we're choosing between a0 being 0, a1 b1, right? We want to find the average of the GCD over all these possible choices. In order to avoid floating point precision issues, we instead use the following output method. Suppose the expected value of the greatest common divisor of the xi is p by q. It can be brought into a form like p by q. The right, it can be brought down to a rational form. So p and q are relatively prime positive integers here. Find an integer n between 0 and 1 0 0 0 0 0 0 0 0 0. This is 10 to the power 9 plus 7 minus 1. Basically, I'm going to call 10 to the power 9 plus 7, which is this number, as mod from this point on, right? So this is mod minus 1. Find an integer between 0 and mod minus 1 inclusive, for which p plus q star n is divisible by mod, right? So usually what happens is, let's ignore the above part, the actual question part. Let's focus on the below part, which is if the greatest common divisor is p by q, then we have to display, uh, choose a some number n such that p plus q star n is divisible by mod, right? So what is this? Generally, what happens is we want to avoid floating point precision issues, because if we select float or double in our answers, the uh, integer part or the decimal part is going to vary, right? It's not going to vary. It's going to be really inaccurate. If the answer is, let's say, in the order of 10 to the power 50, then it's not really going to consider about what is at the units place, right? So we want to avoid that. We want to avoid that any loss of information over here. So instead, we want to calculate the number in modulo mod, right? So that we can keep the information, keep the all of the information. No information is being lost here. Some information is being lost here, but the number are coming in a nice fashion, and we can check if the numbers are correct, coming correctly or not, right? So this is just checking that. I'm also going to first explain that how do we do something like this, and then I'm going to explain the above problem, how to do this problem, because that is a main problem here. So input will have t test cases. Each case will begin with a number k pairs of integers ai, bi follow, etc. For each test case, output the value n, standard input output. The constraints are t, the number of test cases is around 50. The number of pairs of ai comma bi is between 2 and 5 only, right? So there can be a0 b0, a1 b1. These are 2 pairs, or up until a4 b4, these are 5 pairs, right? So a0 b0, a1 b1, a2 b2, a3 a4, a4 b4, right? These are the 5 pairs. I can only have at most these many pairs. But the number, the pairs can have values up until 2 into 10 to the power 5, right? 1 is less than equal to ai, is less than equal to bi, is less than equal to 2 into 10 to the power 5. So here is a sample input. I'm going to ignore the rest of the test cases for now. Let's focus on the first test case, which is a0 b0 is from 2 to 4, and a1 b1 is from 3 to 5, right? So in here, they have made a nice table here. So from 2 to 4, the numbers can be written as 2 and 3 and 4. And from 3 to 5, the numbers can be written as 3 and 4 and 5. They have calculated the GCD of each combination and written it in the table itself, right? So the GCD of 2 and 3 is 1, GCD of 3 and 3 is 3, GCD 3, 4 is 1, etc. So the sum of these values, we want to average over this value, right? So the sum of these values is going to be 15, and the number of values is 9. So a denominator of 9 ensues here, right? So the number, the p by q form is actually 5 by 3, which we want. And if we look at this number, which is 333, 333, 334, if we multiply that by 3 and add 5, it's exactly equal to 10 to the power 9 plus 7, which is mod. So the answer is 333, 333, 334, right? So let me switch to my whiteboard. First explain how are we giving the output, and then explain how do we solve the problem itself, right? So in this, first of all, let me just clear my canvas. Wait a second. All right. So the problem name is greatest common expected GCD. Expected GCD, right? So first of all, let's focus on the part which we talked about was in the last of the question, some P by Q. We want to have some N, right? Such that P plus Q by N is divisible by mod, right? And what is mod? It is 10 to the power 9 plus 7, right? So what do we mean by that is P plus Q by N modulo mod, and this is pertaining to modular arithmetic, right? Let me actually, instead of writing this percentage value, let me write this as in mod some let's actually replace this mod by some other number. Let's type this as m, right? So there won't be any confusion between this mod and the m that I'm going to write here. So the m here is 10 to the power 9 plus 7, right? So P plus Q by N mod M is 0. This means that P plus Q by N is divisible by M, right? So in here, P mod M is going to be minus Q of N mod M, right? Just standard modular arithmetic. Whatever the value comes after we do P mod M is going to be the same as when we do minus Q N mod M, right? So in here, we can take the minus q from this side to this side. And when we take these values in from right hand side from left hand side in modular arithmetic, what we do is we multiply that number by the inverse of q minus q, right? So the inverse of minus q in mod m space, whatever the value of minus q inverse comes in mod m, we're going to use that. We're going to multiply that p and output that modulo n, because that is n mod m, right? We want to have this n. The n formula comes nicely over here, which is basically n is equal to minus of p q inverse mod m, right? So this was the part in the last that I was talking about. And if you don't know how do we calculate modular inverses, I recently took a lecture on this as well in my plus course, or you can check it out from some online resource as well. This is really important in modular arithmetic, how to take modular inverses. But if you don't know, if you don't know about modular inverse right now, you aren't going to have a problem with the solution that I'm going to explain next, right? So you're only going to have problem with this part of the solution, but the actual solution that I'm going to talk about, let's talk about that. And you can follow me on there as well, right? So we have some, the average GCD value, the answer that we want is actually nothing else but summation of the GCD x0, x1, etc., xk minus 1 over all cases, right? This is all cases by number of cases. This is actually P by Q, right? Nothing else. So we just want this value. So what is this value? I'm going to write this in another fashion, which is we want sum of GCD in all cases. Let's write this in another fashion, which is summation of summation of I in every number, right? I in all of the integers or all of the natural numbers. So we're going to sum for every I in natural number. What are we going to sum? Is we are going to sum this value, right? X0, X1, etc., xk minus 1, such that I is equal to this GCD, which I have written there, right? So I just breaking down this summation part of all cases as I in natural number and I is equal to GCD. So how many cases there are such that I is GCD? How many cases, right? How many cases are there such that I equal to GCD? For all those cases, I'm going to sum this GCD part, which is going to be I itself, and then I'm going to sum it over I in N, right? So what I'm trying to say is, let me write this in a better format. GI, I'm going to define a function, right? Let me actually make that Gn instead of I, is better that way, or X, right? So this is the number of cases such that GCD of x0 comma x1 comma etc xk minus 1 is equal to x, right? This number of cases is problem to problem dependent. It's not going to be a global function, right? But this is the function gx is equal to the number of cases such that GCD x0 x1 etc is equal to x, right? So what the answer is going to be, what I have written before, is answer is just going to be the summation of x in natural numbers over uh, x gx into x, right? Is going to be summation of that by number of cases. This is going to be the average GCD, right? So we are just taking the frequency of this is the frequency part. How many times this GCD has come, which is x, right? And then we are multiplying that by the value itself. This is a standard average solution where we're just taking uh, the frequency into the uh, value multiplication and dividing that by the total number of cases, right? Let just give me a second. I'll come back after uh, muting here, right? So let's go to the next part here, which would be to calculate gx, we need another function, which is fx, right? And what is going to be fx here? Let me write down fx as well in proper English. Fx is going to be the number of cases such that the GCD, right? The whole GCD is a multiple of x, right? This is the important part. It's a multiple of x, not x itself is just a multiple of x, right? We don't know what we are using this function right now for, but I'm just defining this function because I'm going to use this function next in the solution. But fx is the number of cases such that the GCD is a multiple of x, right? And then do we have a nice equation for gx using fx, right? Let's say we have calculated all the fx, right? And we want a equation for gx only. That can be done by gx is equal to fx, right? Minus something, minus the number of cases. The GCD is a proper multiple, right? Proper multiple of x. And what do I mean by proper? is just that the multiple, which is let's say some k, right, is equal to some t into x. Here, t shouldn't be equal to 1, right? T should be some greater than 1 value, right? So the number of times the GCD is a proper multiple of x, we're just going to subtract that from fx and we are going to get gx itself, right? So gx is the number of cases the GCD was x, fx is the number of cases such that the GCD is a multiple of x, and here we're going to type the number of cases the GCD is a proper multiple of x, right? So let me write this down in terms of gx as well. So gx is equal to fx minus g of 2 into x minus g of 3 into x minus g of 4 into x, etc. This will go up into whatever range limit we have, right? So g into n into x, or can go up until to infinity as well, right? So this is the final formula that we are going to use to calculate gx from fx, right? This will be done in a C fashion. We're going to look back at this formula in a bit, but let's now look at how are we going to calculate fx itself, right? So fx can just be calculated by uh, uh, how many multiples of x are in a0 up until b0, right? This, let's say if k is equal to 1, right, then fx is just going to be how many multiple of x are in a0 into b0, right? It's just the number of multiples is going to be fx itself, right? But if there are other pairs as well, like a1 b1, so we are going to multiply that by how many multiples of x are in a1 b1, right? uh, the number of multiples we have in a0 b0, if we just multiply that by the number of multiples we have in a1 b1, uh, fx is just going to be that value, right? And if we have more number of pairs, we can multiply this by next as well. This is happening because wait a second, the definition of fx, right? The number of cases such that the GCD is a multiple of x. That is the definition of fx. So in all of these cases which we are multiplying, right, if we pick up k1 x here such that k1 is greater than equal to 1, if we pick up a k2 x here and we pick up a k3 x here, the GCD is still going to be some multiple of x, right? So we can just multiply these choices and then we are going to get fx. So generating fx is going to be simple, and then generating gx from fx here. For to calculate a particular value of gx, we will have fx there already, and then we'll just look at all of the multiples that g has. And this is a thing that we can do in C or Eratosthenes. For every number we look at the multiple it has, right? So that is going to take big of n log n time, right? So I think I should summarize the whole solution and then we'll get into the coding part. So the solution overview is just first calculate fx using this multiplication, right? So in a1 b1 multiplied by a2 b2, etc., right? Just give me a second. Then we are going to calculate gx, then calculate gx for every gx, not only for one x, right? Calculate gx using the sieve method, right? And then calculate the summation of x into gx for all x in natural numbers, and then divide that by the total number of cases. Total number of cases would just be b0 minus a0 plus 1 into b1 minus a1 plus 1 into like this, right? Because we can take a b0 minus a0 plus 1 numbers from the first range, b1 minus a1 plus 1 from the second range, etc. And once we calculate this, we calculate p as this and we calculate q as this, then we're just going to output minus of pq inverse mod m, right? So this is the overview that we are going to do in a solution. Let's code this and I'll detail what step I'm doing at each part. So let me share my screen, which I'll be sharing Visual Studio Code. Let's go to a new file and remove all of the unnecessary parts. Right. So first we'll be taking the input, the standard procedure. We'll just take the number of test cases, and then we'll take the number of ranges we have as n. It's k in the question, but I can replace that, right? So then we'll have two arrays regarding a n and b n, and then we'll just go from 0 to n and input these two arrays, right? ai, bi. We will take these pairs one by one. And when we do have these pairs, what we're going to do is first we are going to make the fx, right? So for fx, what I'm going to do is I'm going to, because the range is 2 into 10 to the power 5, I'm not going to declare the fx array again and again. I'm going to use the same array, but I'm going to declare that here, which is static constant int n is equal to 2e5 plus 5, which is basically 2 into 10 to the power 5 plus some extra memory to avoid memory exceeds, right? Not memory exceeds, runtime errors. Then I'll take static constant int mod as 1e9 plus 7. Then I'll generate the two arrays, which are fn comma gn, right? And then for each number from I equal to 1 up until n, what I'm going to do is I'm going to calculate fi, right? Fi is equal to 1 in the start. And then for each pair of ai comma bi, I'm going to multiply fi by the number of multiples, right? And how do I know the number of multiples? That can be calculated as bi by n, the floor of bi by, sorry, not n, it should be I, right? So bi by I minus what should be the next number? It should be ai minus 1 by I, right? So it's going to be something like that. So in this case, I'm just multiplying fi by this number, this giant number that I have is this, right? So it is basically, there are some bracket issues. Let me clear that up first, right? So this bracket correspond to this bracket correspond to this bracket, this correspond to that bracket, right? So modulo mod, right? Modulo mod. Then once this is calculated, this will calculate the whole of the FIs, right? Then I'm going to calculate GIs, which would be in the fashion of for int I equal to 1, for int I is equal to n minus 1, I is greater than or equal to 1, I minus minus. I'm going to calculate that from the reverse because I need g2 star x, g3 star x before I calculate gx, right? So here gi is nothing but fi, but I'm going to go at each of its proper multiples. Int j is equal to 2 star I, j is less than n, j plus plus. This is the sieve like loop that I have, which is going to work in n log n, right? In here, what I'm going to do is gi is equal to 0 ll, to typecast this into long 0 ll plus gi plus uh, mod minus fi fj, sorry, and modulo mod. So this is just me subtracting fj from gi, right? And this would give me the whole gi value that I need. So this is calculating fi, this is calculating gi. I have completed two of the steps in the overview. Then I need the third step, which is calculating the sum of these values, right? So let me take another int answer equal to 0. And for each of I in the range 1 to n, I'm going to answer is equal to 0 ll plus answer plus I star gi. And before I do I star gi, I want to typecast this into long because otherwise the value would overflow, right? So I'm going to do this a mod here, I star gi mod, and then another mod here. This is going to calculate my upper value, which is answer P. Let's say this is answer P. And I have another value to calculate, which is answer Q, right? I'm going to declare that as 1. And for each n, which is each pair that I have, I'm just going to calculate answer Q just equals to 1 ll star answer Q star bi minus ai plus 1, right? This is the number of values it can take, modulo mod. Then I just need to calculate what is the modular inverse. And this is a function that I'm just going to take from my standard template. You can learn about how to do modular inverse, but this was not the focus of the topic. So I'm not going to use another, I'm not going to build a function for modular inverse, right? Right. So this should work fine. And then I have to output mod minus P answer P 1 ll star modular inverse of answer Q. And modulo what? Mod, right? So this would calculate answer P into inverse of answer Q and the negation of it. The negation is written here, mod I minus this, right? So this would calculate minus P Q inverse modulo mod. So let me try to run this on the sample test cases, and let's see if the answer is coming out to be correct. There seems to be some error because it's not working currently. Let me look at my code for a second. but the solution is going to be of the same idea. You maybe there is some bug in my code which I'm not able to find right now, but the solution part is exactly similar, which I'll just overview one more time, right? So first we have to calculate the fi, and fi would nothing but the multiplication of bi by I minus ai minus 1 by I, which is the number of multiples ai up until bi has, right? Oh, I have to include j here. I have found one bug in my code, right? Uh, then I'm going to do gi minus fj. This code is correct. This is sieve-like method where I'm subtracting from gi. Here as well, I have to include gj, not fj, right? I have found another code like this. So I have to subtract gj, not fj. Gi is equal to gx is equal to fx minus g2x minus g3x and so on. That's why gi I'm initiating as fi, and for every proper multiple, I'm subtracting gj from it, right? Then the next part, answer P, is just going to be I star GI summation. So I'm doing that correctly, I think. And then for answer Q, I should be using J here. I'm not sure why this didn't caught up in the compile part. And yeah, I'm doing this part, I think, correctly. So let me compile this one more time. And let's run this on .a2. So it's stuck in some infinite loop. Let me check really quick, see if I can find what kind of loop it isn't stuck in. J plus equal to I, right? This is one part which I should have included. Right, so I think the answers are coming out to be correct. Yeah, those answers are coming out to be correct. So let me actually copy this code and share my screen onto my code chef, right? And try to submit this problem. It was a little complex problem because I couldn't run my code on the first try, right? There will be some bugs when you try to code it yourself. Let's try to submit that and see if this works. Hopefully it should give an AC. But I am not using LL right now, so it might not give me an AC, right? So yeah, it's an AC, perfect. So I will be taking doubts now. This concludes the problem solving session. I'm guessing there might be many doubts pertaining to the second question. So if you do have any, ask me those and I will try to see if I can answer them. How did you go from sum over all cases GCD to the sum over all n sum I equal to GCD? Right. So that was incredibly simple. Let me just share to my whiteboard, right? So the doubt asks, how did I go from this to this, right? Which is basically, I'm summing GCD over all such values. Let's try to make a frequency array, right? So in one case, the first case, I'm not sure what case it will be. I'm guessing it will be the when the numbers are A0, A1, etc. up until AK minus 1. Then the next case would be A0, A1, AK minus 1 plus 1, right? There might be some case finally at which the case is B0, B1 up until BK, right? So we want to take the GCD at each of these cases. Let the GCD here be 5, let the GCD here be 6, let the GCD here be 5. So what I'm doing in this part is just making a frequency array, right? A frequency table, which means when my GCD is, let's say some 5, how many cases come here? Which would be, in this case, let's say there are only 2. When the GCD is 6, how many cases are coming here? it's 1, right? Let's say when the GCD is 7, there are 24 cases coming here. When the GCD is 5, the number of cases coming out to be 12. So I've just replaced the summation part, which is for all I in natural numbers, which means for all I in the, for all columns of this table, like for all of the possible GCD values, right? I'm checking how many times GCD has come out to be I, right? And summing those GCD values. Basically, I'm doing, this is more visible by this case, which is for all X in natural numbers, I'm doing GX, which is the frequency this GCD X has come into the GCD itself, which is X, right? So that's how I have went from this summation for all cases GCD of this to this summation, which is just frequency into the value summation. Are there any other doubts which you guys might have? All right. So if you do have any doubts, like if you do come up with a doubt after solving this on your own, you can contact me on Codeforces or CodeChef, whichever you prefer, right? Or you can go up to Unacademy. There is a messaging feature there as well, right? Right now I'm going to end this lecture. If you did enjoy this lecture, there is a feedback form below. Please do fill out that feedback form so that I can gauge, like, did I perform good, and what areas do I need improvement. So the feedback form will be down in the description, and please do give your feedback. And yeah, I hope you enjoyed this lecture, and I hope you learned something from it. So this will be all from me. Bye. See you in the next lecture. All right.